if you see that I didn't start recording, please remind me. I have a big note on my desk. I always forget. Thank you.
Olga, you are the best partner ever.
Annie, please. Thank you.
Okay, thank you and welcome back. So today I'm going to go down the path of artificial intelligence, and this is somewhat of an introduction. It does get into, quite foresight out there as to where artificial intelligence can go. And I will talk a little bit about, where it interfaces kind of with knowledge management. So the pre-class assignments basically was a reading on the state of AI and intelligence automation in business. And as you probably noticed, most of this is focused on business. Excuse me. Okay. And then the state of AI in 2020. And our question is, what are your thoughts on the risks associated with pervasive AI, which we've been kind of plunged into? I'm going to talk just a little bit about the background of it. I'm going to, not very much, but then I'm going to look into, pretty much what AI is and its components, and then later on talk about some of the issues and limits that fall around AI. And, interesting enough, the value components. And even as of today, I looked at a survey and 55% said that AI should be focused on value. So we're going to talk about that value component. So one thing about artificial intelligence that when we look at, remember, artificial intelligence is emulating real life or reality. So it's looking at the intelligence of man and is trying to capture it so that it can put it into computer systems. And it uses all of our senses as well. So with artificial intelligence, we're doing things with how do we actually simulate the way man sees things, the vision part of it and sensors. And also, how do we begin to have that dialogue and speaking with humans in a language that they understand, interpreting it through a computer. We look at things like decision making, which makes it a little bit more complicated, because when we get into decision making, we're actually getting into a very complex area, because within humans, all of us do not think alike. We have robotics when we start thinking about the routine things that can be done that are pretty straightforward. And then learning, how do you, as humans, actually grow in that area of knowing how to do things differently or better, or learning so that you can improve. And last but not least, planning. Planning is a really big factor, because in most of our businesses or anything that we do, we tend to plan, we strategize. And so we need to capture that as well when we're dealing with artificial intelligence. So let's look at this. I've stated before that artificial intelligence is not new. I know in most cases, we'll say that it kicked off in 1956 at the AAAI conference, but it actually started way before then. Mankind has always been trying to realize how do they capture the things that they're doing in business and then move them forward. So I take you back, and there's even some that may take even back further than this, or you may realize that I'm missing some, but I just take you back to 1865, where, Millard Nevins decided that he wanted to capture certain things in business so that they could be shared. And then moving forward to 1958, when Peter Lund looked at it and said business intelligence, which was the first coin of business intelligence and technology. And then we get to AI when we get to 1956 at the AAAI, and John McCartney actually coined the term artificial intelligence. And then we realize, it's not just intelligence. Where we're going is through the thought process, because we have to think. We can put intelligence out there, but if we don't eventually know how to use it so that we can think and actually reason with it, then, it might not be successful. So that's when we went into that cognitive science era, and we began to realize that, there were more stages to this intelligence than just, building intelligence. And then we circled back and we came with Peter Drucker, who in 1990 coined the term knowledge management. And so knowledge management took off. And then we moved into 2005, where we got with big data. So as you can see, these terms have been floating around for a while, and it seems as though we're doing them in stovepipes. And I'm hoping that now we're coming to a point where we have convergence, that we can bring them all together. And even though it's a complex structure, that we can begin to realize how we can actually evolve into these intelligent computers that we need, augmented by humans, of course. And that might be just my view. It's not new. We got biomimicry. We've done this before. You know, we've used animals. We've used nature to determine how we're doing things. You know, we had dolphins with communications and underwater, and, you know, then even termites about architecture and how to build buildings. One of the things that is current, we had birds, aerodynamics and flight. You know, we watched how they were able to fly, and we captured that into airplanes. And not only did we capture that in airplanes, you know, one of the things that I always say to people, they say, well, we're getting autonomous cars, and it was all this hoopla about autonomous cars and cars driving themselves. And I say, okay, do you realize that we've had autopilots for quite some time? So this is very similar. So planes have been flying themselves, augmented by humans sitting there in the event that something happens or there's a problem. So this is the same sort of evolution that we're looking at with intelligence, but we're now moving into humankind, which is a little bit more difficult because you begin to start to understand how the brain works and the neurons. One of the things that I also want to emphasize is artificial intelligence can be used. We focused on certain areas, but you got products that use artificial intelligence. And a lot of times that's very structured because you know what the outcome is and you know what you're going to be building within products. And then you have process applications, which become a little bit more complex because then you start thinking about how to improve. But in most cases, when you have procedurals to get from an input to an output, it's pretty structured, a little bit more dynamic, but you can actually add areas or actually gather information from it for improvement. And then on the third piece, I need to lower this down so that I can. On the third piece, we have insight applications, which is where we're really looking into now. You know, how do we actually be able to improve based on predictions, and even moving forward into diagnostics and things that will help us to actually apply our knowledge quicker. When we look at AI and even putting it into perspectives, there's several types of enabled machines that we can look at. And this is sort of like what I was just talking to. You can have reactive types of AI where you know what's going to happen. So basically there's no memory involved. It's just a stimulus that tells you to do something and you do it. You can have limited memory where you learn and improve on the responses. And then, you know, it's sort of like a slight feedback, but then we're getting into, again, theory of the mind. We understand the needs of others and we'll be able to respond to that. And then self-awareness, where it begins to think like humans, which is where we get into, again, that common sense area, and a lot of times we don't understand that. So as we're evolving through these different types, we see we're growing in them, and we have some hybrids. You have some that are reactive with some theory of mind. You have some that are limited memory with some theory of mind. So, you know, we need to think about what is it exactly that we're trying to do within these AI systems that we're building, and then draw that into how and what levels we're putting into our organizations. Again, there are 3 levels when we look at, and I've always been a follower of Kurzweil because, you know, he did that first machine where you could actually speak. And this was to help enable people who were blind within the federal government when they first purchased the Kurzweil readers. But he seems to be an excellent person for prediction. He tends to be able to predict what will happen because he's been working in this area for so long. But there's 3 levels: artificial narrow intelligence, which we've experienced, like IBM Watson, Deep Blue, Alexa, you know, Siri, Cortana. All of these are pretty much structured and based on stimulus and response. Okay. And then you get to the Turing test, and, you know, that's when you have a computer on one end and you're on the other end, and you can't distinguish whether it's a human or a computer, which means that you've kind of crossed that line of being kind of equal to the intelligence of a human because it's responding. You look at fictional characters that came out like HAL 9000, and it also leads you down the path into how it turns evil because it begins to capture the human intelligence when you're talking back and forth and it's storing it. So it begins to behave that way. And then when you get to artificial super intelligence, it exceeds human intelligence, and you start looking at the fictional character of Vicky. And Vicky stands for like virtual interactive kinetic intelligence. Basically, again, begins to protect mankind, but then becomes overprotective and thinks that mankind is a danger to itself. So eventually it protects mankind by enslaving it. So mankind can't do anything, the computer controls them. I don't think we're not at that level of singularity yet. I don't even know if we're at the level of equal to human intelligence. Some may say we are, but I think that we still have somewhat of a distance to go. So let's come back to the components of AI. When we look at these components, again, we want to be able to talk in a plain business language, or a plain, I want to say, language that can communicate back and forth with a non-human. We want to be able to see the vision. We want the computer to be able to see what's going on and to respond and talk to it. We want to be able to learn and reciprocate through the computer so that we know that we're doing things quicker. Robotics, this is a field that I absolutely love because I think this would probably satisfy a lot of things of routine tasks and even elderly care and people who are handicapped. Expert in decision systems, we start getting into that thought pattern. And in the past, expert systems, and we're going to talk about this a little bit too, but expert systems, they tried with this before and it was limited by the capacity of the computers, but now we no longer have that problem. And then planning and scheduling and optimization, we plan and we schedule and we try to optimize. But even though we have the skills to do this, it moves so quickly and there's so much to maintain over a course that it tends to get out of hand. I know that when I read the Frederick Brooks, The Mythical Man Month, who talks about especially even project planning, it's been 20, 30 years and nothing has changed and we haven't evolved. So therefore, it must be an area that we can improve by capturing intelligence and helping us along the way to monitor, optimize, schedule, and plan. Okay. Let's look at language and think about the areas where language comes in at. I want you to notice on the left side is recognition, responder, processing, and interpreting. And we still have that basic input, output, and process. Because when you have a recognition, you're actually capturing something and inputting it. So we have things such as speech recognition, handwriting recognition, optical character recognition, and so forth, and even down to emotion recognition. And a lot of times emotions are picked up based on facial expressions and the things that we do or body movements. So this is not something that's simple, and this requires quite a bit of coding and understanding and repetition and such. So then we look at, when we get to the responder, we're talking about what the outputs are. So based on what we're getting in, can it spit back or can it give us back natural language generation, so that if we're understanding what's saying? Can we do speech synthesis so that it can understand, or we can understand what the computer is sending back to us based on what we've inputted? Robotic process automation, more of automatic workflow, being able to, move things along without having to wait on human intervention. Application programming interfaces, which is going to be extremely important because all of these systems and the fact that we're going into microservices and different types of services, we're going to have to be able to pass data back and forth between these small applications. This reminds me also back with systems engineering when we used to do, tightly coupled, but loosely coupled but tight cohesion. So we would have things independent, but then you make certain that you had the proper interfaces between them. And then text generation. And then we get into, how do we set this up? So We bring things in recognition, we start processing them, we translate them, we transform them into what we want, and then we respond with what the way that we need to communicate. And last but not least, we're doing the interpretation. And this could, once again, when we get into these types of fields and we get into the interpretation, we also need man's intervention. So once again, even with language, we need to make certain we have the proper things in place to ensure that it represents the company and not the individual. Vision, once again, at the forefront, you have the recognition of the image, and then the machine vision, or the machine interprets it, locks it in the machine language, and then it gives you a visualization so that you can see. Now, the interesting thing about even with vision, you know, it works with a lot of images and pixels and formats. So what happens is, if you change maybe one coordinate in an image, you could change something to be dangerous that is not dangerous. So this is another reason why when we look later, we think about, like I was saying, transformation, security on all of this. You do not want to allow, or if someone is capable of modifying vision or any types of algorithms that we have within the system, because it could cause legal ramifications as well as personal ramifications against people. When we start to learn and reciprocate, you've probably heard this language. This is when we get into machine language. And can somebody mute there? Thank you. When we get into machine language, we're looking at the different types of algorithms that we're writing, and usually it's like supervised learning, and that's where you know what the outcome's going to be. It's pretty straightforward. Unsupervised learning, where you know you're gathering information so that you can determine, you're helping to train. Reinforcement, you're like, sort of like with AlphaGo, it's getting a token so that it knows it's on the right path, it stores it, and then it goes back and it keeps for reinforcing it so that the algorithm is actually learning. We do classification and clustering types of activities within the machine language to give insights into things that have relationships and are working together. And then you got that deep learning where you go from the top and you go down to the primitive level so that you could start to identify some of the causes or some of the relationships that may impact the outcomes that we're getting. Data mining, we jump in and we start mining to see if there's any types of relationships that are unknown, what things that we do not know that we can actually bring together and begin to actually operate a little bit differently based on what we're finding in our mining, and innovation, new things that we can also bring out. And then recommender systems, you know, things that looked in the past and come back, and based on, you know, past activities or based on past history, it can actually recommend different paths for you to follow in the future. When we get to neural networks, there are several kinds of neural networks too. You got the convolutional type that give you layers. So you have layers as to how you get that sequence of events. I mean, even things as simple as putting a sentence together requires you to have a certain sequence in order for it to make sense. And then you have recurrent types where they bring in functions or activities and link them together. We jump down into analytics. And when we're dealing with analytics, in most cases with artificial intelligence, what you see is descriptive types, or you'll see predictive. And right now, I think that we probably are good with adding the other two, because if we can build the algorithms to actually even look back historically and come up with diagnostic activities, that would be really well, as well as prescriptive analytics. So I didn't limit it to just the predictive that usually comes about when you're dealing with algorithms, because I think that we probably would be on the path to taking our descriptive analytics and our predictive to the next level of prescriptive and diagnostic. There are two algorithm concepts And you're familiar with them because I mean, everyone uses GPSs right now, but it's search and pathfinding. So you have these programs that look for the best and shortest route. And that's one of the main types of algorithms that we're looking for. So, you know, it helps in transportation. It helps in just different types of activities that we're looking to search and find particular ways of doing things. And then you have your next type, which is the predictive modeling, which is using statistics. And this is something that we really need to be familiar with, because I've seen organizations where they will have data, and they will have scientists there, or they will have different skills, but the skills don't bring in things like statistics, economics, and even data analysis and or data management. And those are critical when you're putting together these algorithms, because statistics needs the data, and also needs to be there so that you can, even econometrics, so that you can determine forecasting in different areas of how we move forward in the future. With the analytic methods and algorithms, the one thing that we want to make certain of is their purpose and their fit. You know, if you're working with algorithms, you want to kind of emphasize that, you know, again, they don't start out intelligent, you must train them. So you need to understand what their particular purpose is. Like if you're dealing with naive Bayes, then you know that that's probability. And if you're dealing with something like regression or linear regression, you know that that is the relationship. You don't have to be a statistician, but you need to understand the business terms that apply to these statistics, so that we're using the proper statistics to determine or develop or build our algorithms. And one of the things that we'll go back to again is the foundation, is knowing that fragmented data hinders the process of training algorithms, because if you have incomplete or even incorrect data, then you've already sabotaged your algorithm. So when we talk about purpose and fit, you'll notice that as we take this down and you look at the different ways of supervised, unsupervised, semi-supervised, or even reinforcement learning, there are particular statistics that work within each of these areas. And you want to become familiar with them. You see on the bottom level, it gives you some of the business applications that they fit within, like the housing, medical, driverless cars, optimized marketing. So you begin to do the design or the structure, so that you know that you are using the proper types of algorithms and statistics, and even in inclusion. And I keep saying economics, because I think that's very critical also to being a part of forecasting. When we get into robotics, the one thing that you're looking at with robotics, again, we have the algorithms, because these are products. So we have the algorithms and the intelligence that's built within them. You need to think about what is the purpose of the particular robotic. You know, most of the time you're looking at them performing tasks that are, you know, really dirty for human beings, you know, because they can go out and retrieve things amongst mud and dirt, whereas we possibly would not be as effective at that. Things that are repetitive, that becomes boring, that, you know, people lose interest in. Things that are dangerous, hazardous, and sometimes things are impossible they can achieve. Again, one of the areas that I think is phenomenal for it is the ability to be able to assist handicapped and senior citizens. Even when we have products like autonomous cars, autonomous cars are great for senior citizens that need to go to doctor's appointments but cannot drive anymore. They are, you know, with senior citizens, you have all of this healthcare and or caregiving. Robots can be trained to care for senior citizens so that it can alleviate some of the burden off of the family. So those are areas that I think are really good. And then you have operate equipment with precision. Robots can do things more precise than humans. We know what needs to be done, and we can train them to do these things. Okay, let's look into decision systems. When we talk about expert systems, again, expert systems are built off of heuristics. It's more if then, if then. And the interesting thing is they're not new. They've been around for quite some time, and the hindrance to them was the technology. One of the biggest areas that we could have received a lot of benefit in was the help desk. You know, for years, I heard people complain about the help desk, but we never looked back at that we were supposed to implement it properly. There were 3 levels, and we were supposed to take the expert, and within the knowledge base, it was supposed to be the knowledge of the expert so that the technician could actually leverage the knowledge base. But what happened is it kind of flipped, and the technician was supposed to be the expert, and they were not being paid enough to be an expert, nor did they have the skill set to be that expert. They were supposed to be able to have something that they could use and they could pass on to the user. And unfortunately, I think a lot of help desks failed because of that. So when we get expert systems, the main thing that we need to know is that you have to have the human expert, and you have to be able to represent that knowledge within the knowledge base so that someone of a lesser skill can actually access it, understand it, and convey it or translate it over to a user. And then we have now, which is existing too, but we kind of have a new term on it, is case-based reasoning, you know, or evidence-based reasoning, which is explainable AI. One of the things that we need to be able to do, especially with these algorithms, is we need to understand what it is they're doing, and we need to be able to explain them. So all of the components that go into the algorithms, we need to understand how they fit, what they do, and be able to talk to them. So the explainable AI is very popular right now, and one of the reasons is because we've written a lot of algorithms, and some of those algorithms are written with components that actually don't fit or are not proper for that particular algorithm. Okay, I'm about to take you down a path of intelligence within an organization so that you get a good feel for the fact that we've gone through a lot of AI in products. We've gone through a lot of AI in computer applications, and we're now coming to a point, and I think this is where everybody's beginning to say, well, how do we know that we're doing the right thing? How do we know that this is actually improving our businesses? So I'm gonna actually use the example of organizations or an enterprise when I take you through the fact of how intelligence should be mimicking the brain. So we have, as I had stated earlier, planning, scheduling, and optimization, an area where strategy is very important because the strategic direction of our leadership should be what trickles down into our operations and into the activities that we're doing. And the way that we look at those or measure those should roll back up so that they can see the performance of the organization and then be able to direct their strategy in the proper direction for improvement. So how do we model human intelligence? Modeling human intelligence, and when you think about it, the brain is a tangible organ. So how does it control everything? It controls everything through what we call a mind. And the mind is intangible, and it's all of these neurons that we have that have colloidal effects. So anytime that you go to walk or talk or any of that, it's being regulated by the mind, but it's being controlled by the brain. So what they do is the brain has these vital human functions that tell you when the body is having problems, okay? So this is really complex because in the organization, we basically do the same thing. We start out with a strategy, and that strategy is to go through our leadership so that it can build what we need in order for the operations of our organizations to work well. So in the end, you look at this between the brain and the mind, it's behavior and common sense. And even behavior, when we say common sense, and common sense actually evolves through experience as well as our education. So when we look at this total system that we're thinking about, or this intelligence, we look at it, and with our organizations, our strategy is our brain. That's our tangible that tells us what we're driving toward. Our mind is basically our leadership, and that's what we're trying to capture in our neural networks so that we have the components that they need to think about and so that we can duplicate their thought patterns. Now, you're not going to totally duplicate it because, again, you still have the augmented human that has intelligence that will not go into, or I won't say will not, at this time does not go into the computer. And then you have this body, that's the operations of the organization, that strategy that says, you know what, I want my people trained so that they're capable of developing this product and so that I can get this out the door. And so when we look at the brain and we think about it, the role is every major part of the body, okay? It brings and it regulates the functions and systems of the body. And again, think about strategy. Strategy is supposed to be identifying how to keep or sustain or even renew the performance of your organization based on the components that make up your organization. And I'm going to talk to you about those components in a minute. So when we have leadership and we do these neural networks, you look at all of them that can be automated. Now, this is based on human, but what you need to do is take this and actually convert it into what it relates to in the business. Some of the terms may be the same, some of the terms may differ, but at least you will have that represented. And if it's not represented, that's okay. Maybe that's not something that you're going to take over into a automated environment. So let's think about this, and so that when we get to you'll see where I'm going when I do part of the conversion. What is vital to live? When I go to the doctor looks at vitals, and that tells them that there's a problem with one of my biological systems. And that's where they go. They don't go in at the bottom and say, I'm going to fix this because I'm just going to go by these symptoms. They actually look at vitals first. So they look at your blood pressure, they look at your pulse rate, they look at your temperature, and all of these vitals tell them if you are functioning properly or if you're not. So when you look at the systems that it drives, when you look at like circulatory, it's the nutrients. So they know exactly where to go. This is that neural network. They know exactly where to go in order to be able to give you the proper nutrients that you need. When they look at things like muscular, they know that that's controlling the body and they go in. And this is what has helped them to develop things like artificial limbs, artificial legs, artificial hearts, artificial lungs. That's because they understand those systems and they understand how those systems tie to the vitals. So let's talk about vitals in a corporation. We do so many studies, and with MuleSoft in 2018, I haven't seen any of the later ones. They ask corporate executives, what is it that you need to know to transform your organization, to digitally transform it? And the answers come back, we need to know, IT's operational efficiency, so it's technology. We need to understand our customer experience. We need to know business efficiency, which is business process. We need to introduce new products and services. We need to improve employee experience, and we need to improve partner experience. Now that's 6 areas that have been pretty consistent with what they need to know. So in 2004, prior to doing my dissertation, I actually sent out a survey myself to say, what is it that you need to know about your organization in order to be able to write the proper strategies to manage it. And my emphasis was I needed to find out what the intangible value areas were. And as you can see, all of them are still the same, except for there were 2 additional ones. Competitors, I need to know how I stand in the marketplace against my competitor, and information. The reason for information is because it was found, and there's still studies showing that the average person spends about 10 hours a week searching for information to do their job, and 99% of the time they do not find it. So when you look at these are the vital functions. And when you think about it, what do I need to know? I need to know if my employees are competent and effective and satisfied in different areas. I need to know if my partners are the same. And when you talk about partners, you also have contractors within your business. You also have, supply chains. So all of those with your partners, I want to make certain that people have the right information so they can make the right decision so that they can work. Hello? Technology. I want to make certain that technology is supporting, us. Business processes and operations. I want to make certain that my operations have the proper governance and people have the proper way to execute. Product and services. I want to ensure that my products and services are getting out the door. I also want to ensure that I'm identifying new products and services to meet the market demand, which takes you up to competitors, as well as I want to know that my customers. So if I see these vitals, I know that I am doing okay, and I want to be able to see when they're shifting up and down. So here's where we actually bring in part of that knowledge to intelligence. I want to have an enterprise taxonomy that allows me to build this neural network so that I can drill it down to the primitive level, and so that I can then roll it back up so that I can see if my vitals are on schedule or on task, or if they're lagging or if they're leading, okay? So having a taxonomy helps you to define all of this for leadership, and what it creates is enterprise memory. So it's used as the foundation for the neural network. It paves a way for algorithms and for machine learning, as well as deep learning. And it also gives you a language for strategy so that you can ask the right questions as well as know what is needed to answer the right questions. And the whole thing is you're starting at the top with what's basic to an organization, which is these vital components or vital elements. Now, let's look at it for a second against the neural network. If we say the vitals of an organization are my employees, my partners, my information, technology, process, product, service, customer, and competition, now I want to know what is the function. Remember, because we're emulating what we do within the system, because we have the mind, the brain, and the body that are all working together. So let's look at it and see about our enterprise systems that we kind of talk about. If I had nutrients, remember data management, we represented ourselves in digital. So data management is the nutrients that drive our systems. How do we eliminate the waste in it? We have quality control. So we have to have a control mechanism that allows us to see when we have quality issues and quality, bad things are happening that are causing not efficient quality. We look at protection. We have to have security there. When we have control, we monitor. And here's a big one too, collect and process information. We must have content management. Again, you're seeing a lot of the areas that cross over into information management as well as knowledge management, because content management is core to knowledge management and being able to have those things together. So as we look at it, now we've kind of put it in a language of the business, and we're looking at vitals that we need to track at the high level of visualization that lets me know, you know what, I'm not having a high turnover rate with my employees. My employees are pretty satisfied. My employees are competent to do their skills. And actually my employees are being elevated based on their experience and their know-how to newer positions that we need within an organization. So those are the type of things that we're trying to get at within knowing those vitals. So this is kind of small, but you'll be able to see it. But if you look at this, and this kind of puts you in a different perspective, if I'm starting at the top level, you see those vitals across the top. And in each of the groups, what you wind up seeing is different things that you might want to know that are intangible types of assets. With my customer, I want to understand acquisition. I want to know that, I am bringing in new customers. I want to know, those customers that are leaving. So I want to develop those types of things that can't be told by the tangible elements. I want to know that my customers are satisfied. I want to know how many are dissatisfied. And here's some things that you look at too. I want to know the longevity. I want to know who has been a customer for a significant amount of time that I need to make certain that I keep there. I also want to know those that are coming and leaving and find out the reason why they're leaving so quickly. And you also want to keep your eye on which customers are the profitable ones. What customers are buying my products the most that are contributing to my revenue line. So, and as you look across this, you'll see other things in different areas that you can actually what I call cross-pollinate. You have employees. You want to see, if you were to cross customer with employee, my assignments, what employees are working well with what customers, what employees have a particular education that actually shines in a certain industry. So you can then put together, again, these questions that actually align with what you need to know within the organization. And this is where you're beginning to build your neural network of intelligence within an organization. So one of the things too, if we go back, even we look at Hubert St-Onge and a few others of those that came before, they categorize or they grouped certain areas. And you always saw relationship or organization, competence, or people, and then structure, how the organization is structured. When you cross these, you can actually begin to have insight into what's going on. When you put employee to employee, you look to see employees that influence or impact other employees so that you can actually move people around so that they're working in a better reporting relationship or in a better working environment. When you go and you look at customer to information, how do you influence or impact customer to access to require business information? We now have more customers coming directly into our business processes than we've ever had. So you have customers that actually are part of your value chain. The customer to technology, how do they or influence the automated customer support? How do customers actually use our systems well, or is that driving them away because it's a little bit more difficult? I mean, one of the things that we can look at too, even when we're dealing with customers, the phone system, we automate or we have voice-led, computer-led voices talking to customers when they have problems. And a lot of times what's happening today is people are not calling because they feel that it's not friendly to them. So you want to check into that and see if you're losing customers behind the type of automation that you're using. So again, this helps you bring this into perspective of a business as opposed to a human, because we're changing it over into the proper words. This just gives you a high level, again, of the enterprise intelligence to knowledge. It lets you group, what do I need to look at for relationship intelligence? Do I have the proper intimacies going on within my organization? Competence intelligence, how qualified are my employees? How qualified are my partners? And again, this gives you insight into how to improve people, not necessarily to get rid of them, which is, again, another area of knowledge management. If I know where their weaknesses are and they're capable of improving those weaknesses, then I'd rather retain my employees than get rid of them. And then structural intelligence. Do I have the proper integration with my customers? Do I have the proper integration with my technology, my products, and also processes? So modeling this enterprise intelligence introduces a new level of abstraction. And what it does is it allows you to take it from strategy to tactical to operational models that actually are present today, but we don't have that linkage so that we know exactly where the data is coming from. But to be able to build a neural network based on the language of the organization, it makes it a lot easier to be able to evolve into those models. One thing I want to say is if we're tracking behind value components, they're tangible assets which we know about, they're physical, we can see them, we know money, we know, raw materials, we know offices and stuff like that, which is going to become even even less now that we have more people working remotely. But intangible assets are the innovation, relationships, and experts, and that expertise. And those are the areas that we really need to represent in these neural networks in order for us to be able to improve our organizations. As of 1975, they accounted for 16%. Today, intangible assets account for 87% of the value within an organization. So, your people are an asset, and if they walk out that door, you may lose a lot of valuable, impact to your revenue or your bottom line. The whole thing is, while we're doing a lot of this and we're bringing intelligence in, the one thing that we want to do is make certain that we're valuing our people and their social periphery, because people actually get, their environment can impact them. But intangible assets are the path to our growth, especially since we're building intelligence and we can then represent them within our neural networks and they become more visible to us. So we'll summarize on that neural network structure, which is, building algorithms and thinking about making certain that we actually mimic intelligence, human intelligence within our structures. And I use the enterprise. We want to build an enterprise intelligence in that neural network with subcategories of intelligence that we can use. We should focus on, the algorithms and the explainable AI and knowledge while we're doing that. And one of the good things is that you get a common business language, because you're actually talking in a language that everyone can understand. Doing this and tying it to the right data, you get fact or evidence-based answers, and you get performance-based questions. Automation, strategy formulation process, and also enterprise. Let me hit on that for a second. Strategy formulation has always been around, but this way you actually have the accurate data to make the decisions. I've seen where strategy formulation executives have got to have a full body of people running around gathering information at the point when they're developing strategy. That should be no longer needed, because that data should be rolled up and ready for those who are within the room to look at and to actually add their augmented knowledge to and actually come up with a strategy that's based on evidence-based data. Thought patterns that simulate business intelligence and human knowledge. And again, even with that, we're doing thought patterns, but we still have to think about that tiny piece of augmented common sense and experience that humans have that actually contribute to our final results. This is just kind of real quick, a thought to throw some thought out there. If you're thinking about it, remember, strategy is the brainchild of leadership and management, and it ties to the operations. So question one, is the pertinent data and information being captured to emulate this collective mind in an artificial mechanism? And question two would be, if the answer is not clear and tasks to be augmented by human are unknown, then should there be a concern for the enterprise readiness to implement artificial intelligence? We'll go through these fairly quickly, but it has some other moving parts while we're putting that intelligence into place. Just like with humans, these computer systems or AI, if we're emulating, it's going to fall prey to some of the same things. You're going to have governance, policy around certain things, policy that ensures that the organization is operating in a moral capacity, so to speak, which ties right to ethics, because if you're not aware of ethical and moral issues and it's not built in, then that will put the company at a greater liability, and it also will impact community and also the people who are coming to the organization. And that would take you straight into legal. Even today or yesterday, I read where Jack Ma, Alibaba, got fined $2.8 billion for antitrust violations. So we have to stay on top of how we operate these businesses and what we're doing within them that will impact others as well. Investments, we have to have some format that allows us to, to design top down and to build bottom up so that we don't put these major investments out there and we have continuous failures. So we continue to keep investing in something that's not moving forward. We have to have that map that we know that we're going to have some outcome. We're going to have failures, but at least if we have failures, they'll be at the smaller end as opposed to at the overarching big investment level. But we got to design these networks and know how they work so that we can actually plug them in. And in all honesty, we need to go back to systems engineering so that, you know, we have the design and we build from the bottom up so that we know when we are impacting other activities in other areas, especially since we're getting into microservices. And last but not least, human factors. We want to make certain that, you know, when we are putting these together, that we think about people. You know, even in the past, when people are given tasks that are not of significance, they begin to have behaviors that they feel they're not part of it, or they begin to feel that, you know, they're no longer an asset to the organization. And that can drive certain attitudes and behaviors that can become negative to the work environment. So we have to take into consider, you know, how we have people working, the environment they're working in, work-life balance, and all of the things that we currently take into place. But we got to do that knowing that we're now augmenting people with computers. And, you know, in all honesty, we got to remember, we got to think about if people feel like they're being replaced, what attitudes or what behaviors it'll drive. So regulating AI needs more than policymakers at the table. We need steering committees that cover most of those areas so that we can ensure that we have a well-balanced introduction of artificial intelligence into our enterprises and into our communities. By the year 2030, more jobs will require technological, social, and emotional skills. In the last presentation, I showed that at the top of the list, people are looking at 98% that they have to take into consideration social and emotional skills. They're going to have to look at behavioral science again to determine how we can continue to work effectively with everyone, especially within organizations. Few takeaways. I won't read all of these, but one of the main ones that I want to point out is understand that algorithms do not start unintelligent, they are trained, and also include policy, legal, investment, ethics, and human factors in AI plans, as they may impact the success of an AI effort. So I know that this is kind of a lot, but when you think about it, again, intelligence is what we're emulating from a human being, and not that we have to bring everything over, but we need to at least do the design and lay it out so that we understand that what we're putting together, we can manage and we can effectively sustain as well as renew as we move along. Okay, so what are your thoughts on the risks associated with pervasive AI? Because AI is popping up all over the place right now. And our leadership, do we feel that we're ready to move forward with that? Or are there things that we really need to consider before we move forward? Because we're going to move forward either way, but we must have our plans in order to be successful.
Dear people, this is your time to speak not only on the chat, which I saw was very, very active during this session, but also to join your thoughts. What are the risks associated with AI? I will continue because Annie will have to leave in a minute or two. What are the risks that have to do with AI? Are we on a safe path, or do we have to prepare ourselves before we start, or even when we start, and add some safety belts on our journey?
We have a hand up with Rudolph. Rudolph?
Yes.
Thanks, Edwin.
Yeah.
Yes.
Annie, first of all, I want to thank you. Today was a phenomenal session, and also I think you spoke a little slowly. last time I was finding it very difficult to follow your speech, so I had to go through the recording 2-3 times, but thank you so much. And when I refer to slide 33 of yours, basically when you are talking of intangible assets, the way I see it, that is really where ethics will also come into play, because as we become superior in artificial intelligence, it will start to replace people, and we may be persuaded to increase the intangible assets through artificial intelligence. So I'm not sure whether I'm framing the question right, but it was something that alarmed me when I saw your slide about intangible assets are becoming more pervasive, and AI can actually help in that place. So your thoughts on that?
Of course, Annie is not with us already, but let's talk it. Let's raise it as a risk. One of the risks is how people will we replace people, and even if not, will they be threatened, thinking that that's what we're going to do, and we'll have a new chaos because people are frightened. Good point. Antonella, please add your thoughts.
Thank you. I guess that I also have a question, which maybe is a thought. This is something that I've been, I'm not a super expert of AI. I studied it in my computer science degree, but many years ago. And I think that, even if it was many years ago, I still think that there is an open question around AI, which is the ability of laws and legislation to keep up with it. The speed or the supposed speed of technology is probably really not met by the speed of our legal decision-making systems, our governments, our institutions. So I see the risk as something that cannot be addressed by our legislations as fast or as it is not just a question of speed. I think it's also a question of the understanding, truly deep understanding of which are the risks, because people living in the legal systems are not necessarily experts. I would agree. I would assume that they reach out to experts to get advice, and there are circles around it. But I see that the risk, and I would like to understand where we are today in terms of these of progress in this area.
And even if we have some experts, there always is a very short blanket, because the amount of experts worldwide, globally, it's not even close to what we need. So this is part of the conflict, and yes, a good risk that we have to concern. Thank you. Arif, please.
Okay, one of the questions that I'm facing is that whenever there's something new like AI, which is actually not new, but for management, most of the time is that they tend to rush into getting on board such bandwagon, and then without looking into the readiness of the organization in terms of processes, in terms of technology, and so on. Coming from a regulator perspective, also we're also looking into the rush from a regulatory role where we want the industry to get into AI, because we know that that's the. How do you advise, or how do you assist an organization like this, where knowledge is around, but then trying to get the grasp of what is AI is all about, and then to fit into the whole ecosystem? What are the things that we should do? Should we look at the technology first? Should I look at the business first? Or should I look at the whole big thing? Because I had this question before, and one of the senior management told us there's so many moving parts going at the same time. How do we deal with this complexity? Thank you.
Okay, so we will address this question later on, but as you understand, we also need leadership, and we need some project management, and we have to involve many different stakeholders in the organization to work here together on this area. Thank you. Balaji, and that itself is a risk. Balaji, can you please join and share your thoughts?
Sure. I think in just, I would say that, the biggest threat or risk around pervasive artificial intelligence is pervasive natural stupidity. I think the challenge is some human somewhere is going to train these algorithms, and they're going to introduce biases. They're going to introduce nativity, which is very specific to the mind, which is training the set of algorithms. I think to imagine a more inclusive world, a more equitable world, I think we need to have strong governances and stakeholder participation across the spectrum in how AI standards gets developed in the coming years and decades. I think that's is the biggest risk I sense when anyone talks about pervasive AI.
Thank you so much. Moshe, are you with us?
Yes. So I would like also to point something else, but because when mimicking people, when you learn things from people, and we're people, and I know there is a big problem about it around the world, that you're also mimicking their problems and the things that they failed. And you put a bias in the system, in the AI system that you create. This kind of bias, I don't think we should put into these machines, in this algorithm, because it's accelerating the problem.
Oh, that a great. Okay, may I add that we have a lot of biases as people, and when we go and use the machine, and the machine starts turning our biases to be even more professional and to be even more extreme, that is a great risk of AI. If that's what you was trying to say, we do agree with you. Thank you so much. I saw also on the chat that several people had added some ideas. Mr. Merchant, if you can please, I'm looking for your private name, your first name, and I've missed it. So if you can please speak about the risks as you understood them.
Yeah, good afternoon, everybody. The risk which AI basically has in an organization, especially, is that it displaces, initially at least, jobs which are at a younger level, where the skills are less, and because the skills required are less, the people who are the most vulnerable, they lose out the jobs. I know it has gone through history over the Industrial Revolution also has seen that change, but to manage this at such a rapid pace of change, it is something which is difficult. And how do you mitigate this risk of loss of jobs, loss of opportunities, when AI slowly gathers space and takes out jobs of people? Thank you.
That's a very important point. Thank you, because they're all the time comforting us and telling us, oh, don't worry, we're not really we may be replacing people, but people will have new jobs, new skills, new opportunities. But not always are these the same people that were able to do the job that they did up to now, and not always do they have the skills to do the new jobs and the new and fill in the new opportunities. And it's a great risk that we as society will have to decide how to handle. Thank you so much. Corey, can you please also, I saw that you wrote a few things. If you can please share them loudly so we can all hear you.
So my main point was that we got to look not only at the programming of the AI system itself that you're utilizing, but also the data that you're pulling the information from. Because as the old saying goes, garbage in, garbage out comes into play when it even comes down to even your data sources. So if you have a clean data source that you're pulling information from to make your predictive decisions and everything with, if something gets corrupted with that, it can cause the system to go haywire.
Great. So I think that even I would say, Corey, that it's not only that we have to have clean data sets, sometimes even the best data sets are not the relevant ones for us. And even if we start with very, very highly reputed, good data sources, not always do they come up bringing the best solution for our needs. So data sources is a new type of a resource that we have to learn how to handle, and it's a great risk here. Thank you. Did anyone else want to add, Antonella or Jen? Simon, does anyone want to add? If not, I will add my risk. I think that when we continue and when we will succeed with AI, people will start very, very gradually to lose their abilities and they lose their knowledge in where they were used to to bring up their intelligence and their thoughts and their knowledge. And we look at the experts, if a lot of work will be done by the machine and they will gradually phase out from these places, their tacit knowledge that was not really taken into consideration will be lost for the organization. And even if they have a new skill and new things to do, the tacit knowledge today is not always captured by the machines. And this is a great risk of loss to organizations. And we as knowledge managers, I think that is something that we have to think about in order to see how, when we go further with the machine learning and with the AI, we don't forget the complementing knowledge in the heads of the people, the tacit knowledge, and we see how to capture it, how to use it, how to combine it, so we can really go further. That's it up to for today. I just want to add an ending note. We spoke today about AI. We gave an introduction to AI. We will give another introduction to AI next week. I will be giving the session from a storytelling point of view. We will take the history of AI, and looking at the history, we will stop and speak about some thought leaders, some terms that really were the milestones of AI and how they changed the AI journey or how they drove the AI journey. So that's for next week. So it will be a complementing session. Yet we cannot cover within 2 weeks all the idea of introduction to AI. One of the major parts of major components of the AI technologies is machine learning. So there's a great free to use a book that was published, written and published by IBM. I'm now sharing my screen. Machine Learning for Dummies. I will send you, together with our materials, with our summary today, the link to the PDF that you can download free of charge with no problem with it. It's a limited edition that is free for use. It's only 75 pages. It gives all the essentials. For those who don't have time to read the full 75 pages, I'm going also to send my summary on this book. That's something like 7-8 pages. So it will be very easy to go through the main terms of machine learning that are also the main terms in the AI discipline. So I hope that these additional readings will help us all while we go further into the AI journey deeper and deeper. As to the question for next week, we are not sending you to a specific article to read. We are next week going to work differently. We will start with an open session. As I said, I will speak about the history of AI, about the main milestones. We can start, when you start a discipline, it's a rather interesting question where you start from. And usually you don't start on point number 1, where the term was coined. You start somewhere else where the roots, where the background was prepared, enabling us to start. And I want to send you all to the internet to read about AI, thinking about what we heard today, thinking about the history, and to ask you, where would you pinpoint, where would you put the opening to the journey of AI? And that will be the opening discussion of the next week session. Where would we start AI? Not where the term was coined, but where is the one step behind that you personally, subjectively think that was the starting, the right background, the right infrastructure. From there, AI could go further. So at this point, I thank you all. I will send you later on the summary. I will send you the recording. I will send you the presentation files. And of course, I will remind you of the questionnaire and the WhatsApp. So thank you, dear friends. Thank you, KM colleagues, and have a nice good morning, good day, good evening, and Happy New Year to all. Bye.
Thank you.
Thank you.
Bye. Thank you.
Bye.
Bye-bye.
Bye.
Thank you.
Bye-bye. Thank you.
I will leave the session open for another 10 minutes to those who want to copy the LinkedIn profiles of the people in order to connect one with another.
And if you didn't know, you could go to the chat window, and in the bottom on the right-hand corner at the bottom is a 3 little ellipsis there. If you click on that, you can save this whole chat to your machine. That way you've got all the data.
Thank you, Edwin. And that's the time to thank Edwin, who is not a formal part of our staff, but is helping us every time again and again, also with his good tips and also with the work behind the scenes. Thank you, Edwin, so much.
You're more than
Great.
welcome.
Yeah. Thank you.
Thank you. Bye.
Bye-bye.
Thank you. Bye-bye.
Thank you, and bye, everyone.
So Dr. John Lewis said that there was going to be a buffet today. Where do I get in line? I'm kind of hungry.
Did I sign
I'm
up for
sending
that?
you the link. I'm sending you the link.
It's virtual.
I'm putting it in the chat. You can download your.
Yes, I'm going to download all my omelets.
Yes. Okay.
It's also virtual calories, so that's the good part.
Hey,
Yes.
load up. Eat
I
all you
love
want.
that part. Maybe that's the only
Right.
part that I loved.
Very
Well,
good.
thank you.
Thank you. Thank you. Bye-bye.
We'll see you next week.
See ya.
Thank you. See you next week.
Thank you, everyone.